Hello, welcome to Astronautics for Exploit. This is Dr. Ayoshala Ogundele. Mars versus Earth, comparison of habitability and survivability. The focus points of my presentation are as follows: Mars versus Earth and comparison of habitability and survivability on Mars and Earth. Since ancient times, Mars has been observed and featured in various cultures over the millennia. It provides an avenue for better understanding of the early history of the solar system and how small planets transform in the course of time. According to research findings, over 4.5 billion years ago, terrestrial planets Venus, Earth, and Mars were formed from the same building blocks of minerals and elements. After the formation, each of the planets evolved over time. Venus, the second planet from the Sun, and the only terrestrial object in the solar system, other than Earth, that has a substantial atmosphere and almost as massive and large as Earth, obeys the Sun, always closer than Earth, and this makes it to always appear in the Earth's sky as inferior and at night, as either a morning star or evening star. Venus' thick atmosphere is made primarily of carbon dioxide, with surface temperatures and pressures of about 842 Fahrenheit and pressure of 92 atmospheres. Mars, the red planet, is the fourth planet from the Sun and the third largest and most massive terrestrial object in the solar system. It has a very thin atmosphere and is primarily composed of elements such as iron and nickel that are very similar to the Earth's elements. Some of the features of Mars are impact craters, valleys, dunes, and polar ice caps. It has two small irregularly shaped moons, which are Phobos and Deimos. Mars, often referred to as red planet, due to its reddish color caused by prevalence of iron oxide on its surface, is one of the brightest celestial objects in Earth's sky, and it is believed that it can be viewed from the Earth with naked eye. The surface gravity of Mars is about 38% of that of the Earth. Due to the lack of a magnetosphere, solar particle effects and cosmic rays can easily reach the marine surface. For humans to survive on Mars, they need specially made spacesuits. Various proposals of Mars exploration have been put forward. One of the proposals for human missions to Mars is to be part of the human missions to Venus. The idea is that Venus gravity assist flybys will be quicker and safer routes to Mars with less or the same amount of radiation exposure from the flight as direct Mars flights. Mars versus Earth. Earth and Mars have multiple similarities. For instance, their days are about the same length and they have similar equatorial inclinations. They are also both terrestrial planets that have water. Earth and Mars have several dissimilarities. Earth is much larger and warmer than Mars. While Mars has water, its surface is largely dry, while Earth is primarily covered in water. Comparison of the size of Earth, Mars, and exoplanets of Kepler-20 and Kepler-42 is shown in this picture. Earth's atmosphere is almost primarily composed of nitrogen, about 78%, and oxygen, 21%, with trace concentrations of water vapor, carbon dioxide, and other gaseous molecules. Mars is composed of 96% carbon dioxide, 1.93% argon, and 1.89% nitrogen, along with traces of oxygen and water. Earth and Mars picture is shown in this picture. There are various reasons why we explore Mars, and some of them are as follows: gravity, magnetosphere, atmosphere, water and climate, temperature and seasons, swirl, survivability, and length of day. Gravity. In space, astronauts float around inside their spacecraft, and they are said to be in free fall as a result of microgravity. Microgravity, which causes muscles and bones to get weaker, came into being because of weightlessness. When the pull of gravity is not very strong, astronauts experience microgravity. In microgravity, it is easy to move heavy objects. Astronauts can even move things that weigh hundreds of pounds with just the tips of their fingers. Artist's concept of astronauts walking outside near a large modular habitable base on Mars is shown in this picture. Effects of microgravity. The surface gravity of Mars is about 38% that of Earth. Generally, microgravity is known to cause health problems such as muscle loss and bone demineralization. It is not known if marine gravity will have a similar effect. The Mars Gravity Bound Satellite was a proposed project designed to learn more about what effect Mars-level surface gravity will have on humans, but it was cancelled due to a lack of funding. The picture here shows comparison of gravity on Mars and on Earth. Longer experience in microgravity. Astronauts on the space station spend months in microgravity. Astronauts who travel to Mars will have to live even longer in microgravity. That is because it will take a long time to get there and back. Based on the information and experience gained on microgravity, government and private space companies are leveraging on it to prepare for the effect of microgravity on the astronauts that belong to the Mars. The weight on the Mars and the Earth, comparison of them is shown in this picture. Magnetosphere. A magnetic shield is critical to preserving Earth's atmosphere and habitability. Without it, Earth will resemble Mars, but Earth kept its protection and Mars didn't. Mars is likely wholly devoid of life, while Earth is full of life. Mars has a weak remnant of a magnetic field emanating from its crust, but is a feeble phenomenon that provides little protection. The picture here shows visualization of the electromagnetic currents, remnant current from the magnetism left over in Mars crust. The loss of Mars magnetosphere was catastrophic for Mars, and as a result of lack of a magnetosphere, solar particle effects and cosmic rays can easily reach the marine surface. The magnetosphere prevents the solar wind from stripping away Earth's atmosphere. Without it, Earth will be dry, dead, and barren, just like Mars. The picture here shows illustration of the creation of Earth's magnetosphere. Atmosphere. Atmosphere pressure on Mars is below the Armstrong limit, at which people can survive without pressure suits. Since terraforming cannot be expected as a near-term solution, habitable structures on Mars will need to be constructed with pressure vessels similar to spacecraft, which is capable of containing a pressure between 30 and 100 kilopascal. Comparison of the atmospheric composition of the Earth and Mars is shown in this picture. The atmosphere of Mars is much thinner than Earth's. The red planet's atmosphere contains more than 95% carbon dioxide and much less than 1% oxygen. People will not be able to breathe the air on Mars. The thin atmosphere does not filter out ultraviolet sunlight, and this causes instability in the bones. Water and climate. Water on Mars is scarce. Rover spirit and opportunity. Finding less than there is in Earth's dressed desert. Factually, almost all water on Mars today exists as ice, though it also exists in small quantities as vapor in the atmosphere. The Mars climate is much colder than Earth, with mean surface temperature of about 186 and 268. Illustration of the presence of water on Mars surface is shown in this picture. Because Mars is about 52% farther from the Sun, the amount of solar energy entering its upper atmosphere per unit area is only around 43%. Due to the much thinner atmosphere, a higher fraction of solar energy reaches the surface as radiation. NASA's Mars helicopter that opens doors for flight on other worlds is shown in this picture. Temperature and seasons. Mars has an axial tilt of 25.19 degrees, like Earth 23.44 degrees. As a result, Mars has seasons just like Earth, though on average they last nearly twice as long because the Martian year is about 1.88 Earth year. Mars temperature regime is more similar to Earth's than all other planets in the solar system. While generally colder than Earth, Mars can have Earth-like temperatures in some areas and certain times. Mars and Earth axial tilt is shown in this picture. Swirl. Martian swirl is the fine regolith, a blanket of unconsolidated loose heterogeneous superficial deposits covering solid rock found on the surface of Mars. The material swirl is toxic due to relatively high concentrations of chlorine and associated compounds, such as perchlorates. Artist's depiction of the Habitability unit and the Earth return vehicle on Mars is shown in this picture. Survivability. Plants and animals cannot survive the ambient conditions on the surface of Mars. However, some extremobile organisms that survive in hostile conditions on Earth have endured periods of exposure to environments that approximate some of the conditions found on Mars. The picture here shows Mars ice home design for a Mars base. Length of day. The Martian day, or so, is very close in duration to Earth. A solar day on Mars is 24 hours, 39 minutes, and 35.244 seconds. Mars Sol is a solar day on Mars, that is a Mars day. A sol is the aberrant interval between two successive returns of the Sun to the same meridian, standard time, as seen by an observer on Mars. The picture here shows illustration of Landes force, an interplanetary stage and landing stage as they come together over Mars. For more information, contact Astronautics for Exploit. You've been watching and listening to Mars vs. Earth, Comparison of Habitability and Survivability, presented by Dr. Ayoshola Ogundele of Astronautics for Exploit, with the focus points Mars vs. Earth and comparison of habitability and survivability on Mars and Earth. Thank you.